to Tom. Thank you.
Okay, thank you, Adele. Yes, Martin's still down here, and myself and Thomas Lancaster will be making some presentations now in this first of the 3 sessions this morning. And this work was also done with our former colleague Ben Hockridge, who is mentioned on the first slide. So it's very much a collaborative effort between ADAS and Airbus and CEH in this project. Okay, well, you'll be aware from the flyer that the broader objective here was really to look critically and evaluate the ability of existing and forthcoming near future Earth observation satellites to fulfill the requirements of the agriculture, forestry and other land use, that's AFOLU, inventory of greenhouse gas emissions. And we were looking at the existing track record in recent years and the potential future opportunities for using EO, Earth observation, in this context. So there were several different stages in this first piece of work which we did. They've included, first of all, taking an overview of the Global Research Alliance's inventory requirements. Secondly, then considering a description of where Earth observation is already and is not already used to support the different priority activities, and also some of the non-priority activities as well. Thirdly, considering the technical barriers to more wide stream adoption and operational issues as well, and constraints, and we'll hear more about that from my collaborator Thomas later. And fourthly, trying to tie that together, thinking about the future, how we move forward, how we work together, thinking about opportunities and collaborative approaches that we can adopt to better use and realise the potential of Earth observation in our work for greenhouse gas reporting. So that the survey that we undertook, I'm not going to go through this process chain in huge detail, but really just wanted to demonstrate that we tried to break it down in a structured fashion to show the differences between the priority activities which we're using, remote sensing, Earth observation, and for those we could then consider different types of satellites, different availability of data sets and so on, time frames, costs and so on. But also for those data sets where we were not already using Earth observation, we could consider the future potential, whether that was there was a specific reason for that, whether it was a technological barrier or an internal barrier to do with, for example, costs or availability or training. So there was a branching structure to the questionnaire which we developed that tried to take account of these, the use both of EO in an existing context and the potential for the future. So they're fairly high-level questions, and what we'd like to present, myself and Tom, in the next 20 minutes or so, are the results of that questionnaire, really, and how that, what the implications of that for our future work within the GHD community. So there were 4 broad themes, activity themes for the reporting, and they're headlined here. The most obvious one, which I'm sure you'll all be aware of, concerns land area and biomass. That's an area where Earth observation has been widely used for many years. So that includes base areas for different land uses, arable cropland, grassland, woodland, wetland, and so on, forestry. But then looking at the other 3 categories, starting to think about more management related practices, so short-term rotations, arable crop rotations, for example, or the may involve grass rotations in a grass lay type system, cultivations and the timings of those cultivations in relation to cropping patterns, and then starting to think a little bit more subtly about more perhaps demanding implications like the quality of some of the grassland, and the management of crop residues. So there were some fairly basic data requirements, say under land area biomass, but then some more potentially demanding ones under land management, and it was interesting to see the extent to which EO could perhaps satisfy some of those requirements. And then the other two main activity themes are land improvement, so that's long-term management, so that's issues like drainage or irrigation and typical management practices with manures or fertilizers. Fourth category concerned the degradation of land, so this could be due to soil compaction and erosion, for example, in an arable cropland system, overgrazing in grassland, and the standards of and management of wetland systems, and woodland too, where you might have specific disease issues and dieback or wildfires. So 4 broad categories for activity themes, and they were the ones that we focused on in the questionnaire. There were 44 countries were invited to participate in the questionnaire. In the end, there was a number of reminders, but we got responses from around 10 countries, which was great, and you can see them highlighted in the graphic here. So most of North America, some parts of Europe, South Africa, Indonesia, New Zealand, and that covered a reasonably wide range. Not everything, but a reasonably wide range of different agricultural types. There's a categorization at the bottom there of the different agriculture types that were covered and the number of countries that represented those types of agriculture. So you can see that horticulture, dairy, standard sort of mixed farming, and arable production, grain farming, were all covered within the survey based on the different countries who responded. So we've got enough of a critical mass and a breadth of responses to consider that these results are reasonably representative of many of the land uses that we're interested in this work. You'll be hearing a bit more detail about this from Thomas later, but this is just to present a broader overview about what we found about the priority and current use of remote sensing, Earth observation, in those 4 categories I introduced. So land area and biomass, short and long-term land management and improvement, and land degradation. And the thing that's striking here, well, first of all, it's worth commenting that the cases where remote sensing is already used, which tends to be dominated by the United States, by Canada and South Africa, which together typically around about I think 28% of the cases where remote sensing was used were in the States, for example. So those 3 countries tended to be the most dominant. And the priority activities in terms of historical use was a notable difference in the short-term land management, where we had a greater use of EO remote sensing in the past and current situation, but the priority activities were identified as being rather lower. In contrast, the most popular application area, which we'll hear more about later, was really under land area and biomass, and there's quite a lot of detail possible there. So the most widespread use currently very much under that first category, land area and biomass, but potential for the future in some of these other areas. In terms of data capture methods, well, typically there's an opportunity to use geostatistical survey type information in this type of work, but there is also the potential to bring Earth observation data in combination with that type of survey information and complement it and add value to it, extend it. And it's interesting to see the extent to which that happens across the GRA community. So this chart shows the different sources of information used to capture the activity data that we require. You'll see there's 5 categories here. Field surveys, clearly quite labour intensive, but very detailed and informative. The typical geostatistical surveys and questionnaires that we're familiar with. Expert estimation, where specific information may not always be readily obtainable from the ground, from land managers. Specific monitoring and different types of modelling activities. So 5 different categories here for ways in which we can satisfy the requirements of capturing or estimating or modelling the activity data that we need. What's notable here really is the extent to which the remote sensing is already used in addition to these different capture methods. And you can see from the charts here that it's used in all 5 categories to some extent, less so with monitoring, but particularly in combination with the statistical surveys and field surveys. So it already has a role, and maybe has a wider role in the future, but already has a role established in complementing the acquisition of some of the data sets required to satisfy our reporting requirements for the inventory. So I'm going to hand over to Thomas now, over at Airbus, who's going to walk you through some of the more detailed aspects of the Earth observation details from the questionnaire. Over to you, Tom.
Thanks, Martin. The first thing is at this stage in the questionnaire, we made a distinction between remote sensing, which covers a number of techniques, and the use of Earth observation satellites specifically. And a lot of the answers then drill down into Earth observation satellite usage. So we can see from this pie chart, there's a clear predominance of Earth observation usage for another number of reasons, but most particularly, I think it's likely because of the very large area of coverage that it provides. It's interesting, though, to note that the use of UAVs, which is a relatively new technology operationally, is increasing. But it's, as with aerial surveys, it's often quite complementary to Earth observation data because it can give very sort of well-controlled site-specific detailed information. Looking into the type of usage of Earth observation data by technology.
Next slide, yeah.
Yes, please. What we have here is we have a division up between the, for each different type of Earth observation imaging, we have a division up between the different themes. And as Martin said earlier, you can see there's a very strong predominance for the land area and biomass. In terms of the types of Earth observation data that are used, the visible and the near infrared is predominant. Now, there's a couple of reasons for this. One is because visible near infrared is maybe quite easy to understand and interpret. It's also been available for the longest. If we go back to the very first recognized Earth observation satellite that could see at landscape scale detail, Landsat, back in 1972. So that's a huge record in the visible and near infrared. Shortwave and thermal infrared instruments, and then even synthetic aperture radar, which is able to penetrate the cloud, these have tended to come later, and there aren't as many missions. There's less data availability for these other types of technology, which might explain some of the reasons why their uptake is not as high as the visible and near infrared. Moving on to the next slide, looking at the uptake, again, we're looking at the themes. So if we look at the uptake, we've now divided the uptake for each theme into regular systematic operational usage, operational usage that's more sporadic or on demand, exploratory usage, and research and development. So we've got different maturity profiles. So the most mature, as we've already heard, is the land area and the biomass. And you can sort of see there's a very strong relationship here where there's most of the usage is in fact operational. And then there's a decreasing amounts through exploration and a relatively small amount happening on R&D. So that's reflecting a profile of maturity. A lot of work's already gone into using Earth observation in the land area and biomass regions. So there's relatively little ongoing research and development and exploration, and far more operational usage already. At the other end of the spectrum, if you look at land improvement, all of the work that was reported is split between exploratory usage and even more early stage research and development. So that's an area that's you could say is in catch up, or it's an area where it's possibly harder for Earth observation to meet the requirements for monitoring land improvement. In between profiles, we have land management and land degradation, where there's more of a sort of a balanced mix between the operational usage, the exploration, and the research and development. With the next slide, we move on to a first look at barriers and constraints. Now, this looks quite a rather busy, complex slide. But if we just ignore that complexity, what we're broadly seeing with the different colours here, again, is we're looking at our different greenhouse gas activity themes: the land area, the land improvement, management, and land degradation. But broadly, what we're seeing is that for each particular area where barriers and constraints were reported, we were seeing not a huge amount of difference between what was being discovered for the different themes of activities. If we click forward now, we should see that, yes, I think you can click forward twice. The way the questionnaire was asked for this was, it was a scale of 1 to 5. So 1 was strongly disagreeing, and 5 was strongly agreeing. So the neutral point, where in fact there's no strong agreement or disagreement, is in fact at the level of 3. So everything above 3 is telling us from the questionnaire where we were getting answers from the respondents, where there was they felt there was a particular problem that was constraining the use of Earth observation. So if we go and look at the first of those, the strongest of those was the need for scientific research and development. Then we moved on to the timeliness of the data. How quickly was the data available? The lack of historic imagery was also found to be more of a barrier than people agreed with that. And then related, we have then no standards for the algorithms and uncertainties and error. And those two are fairly similar, and there's a relationship between them. I've highlighted here which of those barriers and constraints is in fact a fundamental constraint: lack of historic imagery. If there was no satellite, for instance, in a base year of 1990, which is a common requirement, then there was no data was acquired there, then we can't go back. It should be said that this also applies to many conventional ways like questionnaires. Often questionnaires that were used for other purposes in 1990 didn't quite meet the purposes of the greenhouse gas activities. So we move on to the next slide. So what's happening that's giving us that's not a fundamental constraint? So various of those issues we looked at before that were seen as constraints, for instance, the need for more scientific research and development, that is obviously something that can be addressed with funding, and as we'll come on to later, with collaboration, possibly between GRA member countries. In terms of the capabilities of Earth observation satellites themselves, the highly used visible and near infrared and shortwave infrared, we're seeing improvements going on then. We had the Landsat 8 launch, continuing the long-term historic Landsat series, and Landsat 7 had some image problems, and Landsat 8 rectified those and also gave improvements in image quality. But moving on from that, we're now moving into having new operational satellites with freely available data, and the resolution coming from, for instance, the Sentinel-2 satellite that we see on the top right there, is down to 10 meters for visible and near infrared and 20 meters for shortwave infrared. Now, for some GRA members countries, that's not a significant change, but for others, as we'll see in the next webinar, that is quite a substantial change. In terms of timeliness of the data, these operational satellites, because they'll be running in pairs, Sentinel-2, there'll be 2 of them. There's one up orbiting at the moment, but a second will be launched later this year. It means going from a single Landsat satellite with a bi-monthly revisit period, we're now moving to revisit periods of twice a week. And we're also moving towards, with new wavebands and finer spectral resolution, we can resolve and characterize vegetation somewhat better as well with these new satellites. In terms of synthetic aperture radar, we now have the Sentinel-1 mission, and we've also got upcoming missions for the RadarSat Constellation, which will give us more systematic coverage and weather-independent coverage, for instance, for looking at soil moisture mapping, and getting this down to 1 kilometers should be happening within the next year or so on a systematic basis. We also have missions looking at longer wavelengths synthetic aperture radar, and the significance of the longer wavelengths is that they will then penetrate further into a canopy. So you can start to get information from within a forest, which will definitely be useful for various things like biomass estimation. Okay, taking another look then at another view in terms of the barriers and constraints. And again, we have this, the question was worded in terms of 1 for strongly disagreeing or 5 for strongly agreeing. So the neutral point, if we click on, is shown here at 3. So anything above that line is where there is a perceived agreement that this is a barrier, a constraint. So the strongest one came out with a lack of staff training and facilities. Now this is interesting because this is something that to some extent could be addressed maybe with collaboration amongst GRA members. The high cost of image acquisition and the high cost of processing and storage also came out as areas that there was a general agreement were issues that were constraining the use of Earth observation data. As I mentioned, because we have the new governmental missions from the European Union, the Sentinel missions, which have a free and open data policy, hopefully some of those data costs at the 10 to 30 meter resolution range should be being reduced. And then there's limited access to data and sharing, and these are seen as constraints. But again, none of these are actually physically fundamental constraints. They can be addressed by investment and by technology developments. So looking now then at the capacity building and collaboration, this is the final part of the survey, focused on looking at how there might be a promotion of collaborative work to increase skills and the information sharing on the use of Earth observation technology in inventory compilation. Respondents were asked to rank these aspects of collaboration to provide a better indication of which aspects they would find most useful. And the highest 2 that stand out here quite clearly is collaboration on standardization and verification of methodologies, and then also on methods and experience sharing network. So again, those are the aspects of collaboration which were most strongly indicated from the questionnaire. Looking then on the next slide, we have a coupling between the use of remote, and again, this is quite a complex slide. There's a fair bit of information, but if you just don't look too much at the detail, but have a look where we've got in the blue, we've got areas where there's a high priority for improvement that was reported by respondents for their activities. But then the green, for almost all of the blue ones, in the green you can see that there are other GRA members who have experience in using remote sensing in those areas that have been identified as high priority. So moving on to a specific example with the next slide. This is like a cross-check table where we took, this was for land degradation inventory activities, and we looked at countries that were either using or were investigating and had information on the use of remote sensing for these land degradation activities. Now, there are a couple of gaps where nobody is doing any work, for instance, with using remote sensing for cropland erosion or grassland water stress. But for all the other areas, there are exemplar GRA members who have already got some experience in Earth observation and could possibly share that with other members who have not used Earth observation yet. I've got a couple of suggestions on the next slide. Move to the next, yeah, of collaboration routes. So this is where, so in the first one, considering GRA countries that are already using Earth observation, we could do a cross-check between the countries using Earth observation, and then set up working groups or joint demonstration projects. The idea being to take people who've got, in a particular activity area, they have got experience with Earth observation, and then try and compare and contrast the different methods and ways that they have used Earth observation. And this would then could progress towards developing the best practice methods, protocols, and algorithms. So it's this idea of standardization and algorithms, and then collectively that then develops an understanding of the new ways of Earth observation capabilities. In terms of another approach, that can be done for by any GRA country, whether they're using Earth observation or not, is that look at the priority activities that need improvement where Earth observation is not currently being used, cross-check that against other GRA members who do have experience in the Earth observation for that particular activity, and then enter into a dialogue or even a joint project, demonstrator project, with the other GRA member. So that's another potential collaborative route going forwards. So summarizing the information that we got from the questionnaire, Earth observation is widely used for greenhouse gas inventory activities. There are variations across the themes in the countries. And when I say widely, that's across different biomes and climate areas and latitudes. Principally, it's the visible and near-infrared data that is being used, and the biggest uptake so far, and the most mature area, is the activities that come under the land area and biomass theme. Land improvement is where there is least usage of Earth observation. All the work there was reported as either research and development or exploration. Earth observation data itself and its application, these are areas that are rapidly evolving. We have costs for acquisition, field scale data have been reduced. The spatial and temporal resolutions are increasing. The spectral coverage is increasing as well, and there's ongoing development within the user communities for processing algorithms. That said, with all this extra data, there comes a challenge because the data volumes are going up. So getting access to the data, downloading it, storing it, and processing it are presenting challenges. Okay, I'll hand back now to Martin for the conclusions.
Thank you, Tom. Yes, just to bring that all together, we've heard in the last 20 minutes or so how there is a great deal of opportunity for further collaboration to try and partner those countries who have some experience of using Earth observation to satisfy the inventory reporting requirements, to try and help encourage and facilitate other countries who currently perhaps have more limited use of EO to satisfy those needs. So specifically, we were thinking of things like use of common algorithms or refinement of algorithms for different landscapes, methodologies for using validation data, and as Thomas explained, that could be done with teaming two or more countries together with differing levels of experience in the use of EO on a per activity basis. So going back to those 4 broad activity themes that we identified earlier. So there's opportunity for training here and for also discussions how to manage big data, which Thomas mentioned, and well, really to tie that all together, we'd very much like your thoughts about how we can take these sorts of opportunities forward in a wider discussion. But before I pass over back to Adele and to the floor, I should just give some acknowledgements to our funders. I know our funder Luke is on the line there from the UK government under in DEFRA. And we should also thank our support from the GRA itself and the facility that we're using today, the webinar facility provided by GRAMP. So thanks to that, all the 3 of those organisations. And I'd like to pass back to Adele and perhaps to Luke to comment on how we might take this opportunity to collaborate forward in the future.
Thank you, Martin and Thomas. Okay, so there's 2 ways that you can participate in the discussion. There's a comments box on your screen, but also it'd be really good to hear from you all vocally. So if you raise your hand, you can make a comment or ask a question.